Read the exercise 5.5. Suppose the diver.
I read already. I admitted. Suppose the diver vaults off the springboard, leaving it with an initial speed of 3.5 upwards. Use energy conservation to find his speed when he strikes the water.
Okay. So as I said earlier, we use the same conservation of energy equation. That is the total mechanical energy initially is the same as the total mechanical energy finally. So the only difference is now instead of zero, you have to replace the initial kinetic energy with this half mv squared, right? So the initial kinetic energy is this one, half mv squared. Uh, you put the m there, even though you are not given the mass of the diver, you just put an m there to show that you know you are actually dealing with kinetic energy. Kinetic energy has the m there, so just put the m there, and the initial potential energy is mg times the height, mg times 10. So this is the total energy before he leaves the springboard. Okay, now as he touches the surface of the water, the final kinetic energy is half mv squared. How much is the v? We don't know. That is what we are going to find out. How much is the final potential energy? Zero, because he is at the zero level. So we try to solve this equation. First of all, cancel all the m away. Cancel away all the m. And this final potential energy is zero. So it will be zero. Just ignore this lah, because it's going to be zero. So what is left is half 3.5 square plus 10g. Okay, so this is what is left. So we try to evaluate this, the total energy, initial energy, with the final energy. So taking square root, you get the answer 14.4 meter per second square. So you remember this, step now. So we are going to make use of this in the following question, right? Wow, this one is slightly different. Okay, never mind. I go through this with you, then you do the other question. Okay, can you read this example 5.6?
A powerful grasshopper launches itself at an angle of 45 degrees above the horizontal and rises to a maximum height of 1 meter during the leap. With the speed vi, does it leave the ground? Neglect air resistance.
The initial velocity is vi, but the path taken is not a direct fall or jump directly upward. Now this initial velocity vi is at an angle of 45 degrees with the horizontal. So you remember the projectile motion, right? So we have to split, or don't say split, resolve, right? We have to resolve this vi into two components, the vertical component vy and the horizontal component vx. The vertical component is influenced by the gravity. The horizontal component is not influenced by the gravity, right? So the grasshopper reached a maximum height of 1 meter. Maximum height means what, you know? Maximum height means it has lost all its vertical component of the velocity. The only component left is the horizontal component of the velocity. Because as as it goes higher and higher, it loses the kinetic energy. So the kinetic energy is converted into the potential energy. And finally, at the peak or the maximum height, all the potential energy that all the vertical kinetic energy that it has is translated into potential energy. So we are going to make use of this fact to calculate the velocity. So how to do it, right? We are going to look at the vertical component only. The horizontal component of the velocity will not change, right? So we look at the first diagram here. Okay. Initially, this is the initial stage. The grasshopper jumped at an angle of 45 degrees. So with a velocity of vi. Okay. Now this velocity vi, we're going to resolve it into two components. The vertical component vi sine 45 and the horizontal component vi cos 45. So this is what we have initially. Now finally, when it reached the maximum height here, the vertical component no more, only the horizontal component left. Okay, so this is the final situation, right, when it is at the maximum height. We're going to apply the conservation of energy on the vertical component because the vertical component is changing. The horizontal component is not changing, so it remains the same. So it is conserved anyway, right? Because there's no air resistance and so on, the horizontal component is conserved anyway. So we don't have to consider the conservation of energy for the horizontal component because horizontal component, there's no change in potential energy, right? Okay, so we are going to apply this conservation of energy equation on the vertical component. Okay, so we're going to look at the vertical component only. Okay, okay, so what is the initial kinetic energy? Initial kinetic energy is half mv squared. Let me draw this. The initial kinetic energy is half mv squared. The initial potential energy is zero because it is at the ground level. So the initial potential energy is zero. Finally, the final kinetic energy is half mv squared. But the v is only the vx. The vy is lost. The vy is converted into potential energy. Okay, so now this is the potential energy. Half mg y. Y is the height. So the height, the maximum height, 1 meter. Okay. Now cancel away all the m. This is zero. This is zero. Don't care about this one. Cancel away all the m and multiply by 2. Multiply by 2, you have only vi squared. Multiply by 2, you have vx squared. Multiply by 2 here, we have 2g. The m cancel away, so we have 2g. Okay, So I copy this equation, Vi squared equals to Vx squared plus 2g. I copy it over here at the top here. There are two unknowns in this equation, Vi and Vx. So you cannot solve. So we have to change it, change this one, the Vx into Vi cos 45. Okay, this one. Vx is actually Vi cos 45. So I change this Vx to Vi cos 45 and the whole thing square. Cos 45, cos 45 degrees is actually 1 over root 2. Cos 45 is actually 1 over root 2. 1 over root 2. Okay, so this is the trigonometric ratio that you need to know. Cos 45 is 1 over 2. So over here, the cos 45, I replace it with 1 over 2. So when you square both the two terms here, this one become Vi squared. This 1 square is still 1. Square root of 2 square is 2. So you have half Vi squared. This half Vi square, you move over to the left hand side, you minus half Vi square. So 1 Vi square minus half Vi square, you are left with half Vi square. Bring the 2 over, it becomes 4g. Taking square root of 4g, the answer is 6.26 meter per second. Now this 6.26 meter per second is the actual velocity. It is not the horizontal or the vertical component of the velocity. The horizontal or vertical component, they have a trigonometric term attached to it, like this one, Vi sine 45, Vi cos 45. So this Vi alone is the actual velocity, it's not the component. Now, one more time, how we go about solving this problem. We solve this problem by considering the conservation of energy. The change of kinetic energy is translated to the potential energy. It is quite difficult to imagine, so we don't think of it that way. We think of it this way. The total mechanical energy before is the same as the total mechanical energy after. So before, half mv square plus mg0. After, half mvx square plus mgh. So we're going to solve this equation and get the initial velocity. Any questions so far?